Minutes we're going to talk a lot about twist, and because we're going to talk about twist, we have to understand wind shear. A lot of people are, I use the word scared of twist. They feel that if the top of the sail is open, they're somehow losing power, losing the ability to point, losing their speed, but that's not the case. The fact is that a sail properly set has to respond to wind shear, and this means that the top of the sail should always be meeting the wind at a different angle to the bottom. And to understand that, we need to take a look on paper and do a little bit of physics. The phenomena of wind shear has to do with the fact that as you get closer and closer down to Earth, or in this case down to the surface of the water, no matter what the wind speed is up high, by the time you get down to level zero, the wind is in fact 0 knots. Now, we've put some arbitrary numbers in here. This is not gospel. This is just so that we can demonstrate the effect of wind shear on the setting of the sail. I've picked 3 wind speeds. I picked a wind speed arbitrarily of 20 knots. By the time 20 knots gets down to the bottom, it's 0. So I put in some intermediate numbers. They're not actual. They're purely to demonstrate this. But we're going to start with a wind speed of 20 knots. Which I will color pink. We're going to go over here, and what I'm doing is I'm going to do a set of diagrams here which demonstrate how you find the apparent wind direction. These are vectors, and I've used a speed of 5 knots as the speed of the boat through the water. It may be 4.8, it may be 5.2, that's not material. And here, this is the speed of the boat, and then at 45 degrees to the boat, again this is arbitrary, it may be 42, it may be 46, I'm putting in on the same vector, if that's 5 knots, that length represents 20 knots. When you join the two together, that is the apparent wind direction at 20 knots. Here it's in the pink. So what I'm going to show is this is the apparent wind direction in pink at 20 knots. And here we are at the top of the sail, and this is the angle that the wind is coming into the sail. That's the angle that the sail sees. We'll go down now to 13 knots. And we'll do our geometry again. And here we have the same boat speed, but now the wind speed is considerably shorter than it was here. It's slower. When we join the points up, we find that we have an apparent wind direction according to the blue. So here we are in the middle of the sail with a blue wind direction. Finally, come down near the deck. We're down at 9 knots. The apparent wind direction again changes because boat speed doesn't change, but wind speed has changed. And now this is the apparent wind direction, and it's at the bottom of the sail. So what we're now looking at are 3 different apparent wind directions seen by the same sail. This is up top. This is in the middle, this is at the bottom. That represents the twist that should be in the sail to match those, to match this curve. This is wind shear, right? This results in the twist which the sail has to have to match that wind shear.